I hope you guys are doing good. So this recording is for paste exercise 3A. This is chapter 3, section 1. The paste exercise has 2 questions. 1, 2. So let's start with question 1. Simplify the expression for the first principal formula, which is given by this. Given that y of x is equals to x to the power 4 plus x plus 1. So the first step, it is to compute. Okay, what do I mean by compute? So you know that your y of x is given by this. So your input here, or your argument, is just x. So now, since you want to simplify the expression for the first principal formula, you know that the first term on your numerator is given by y into x plus h. So for argument x plus h, where there's x, you substitute by x plus h. So you're going to have x plus h to the power 4, that's the first term, plus the second term is just x plus h, and you have your constant as your third term, which is plus 1. So your first principal formula, you compute. So you're going to have x plus h to the power 4. Okay, so remember, we are dealing with the first term, which is given by this. So you're going to have x plus h to the power 4 plus x plus h plus 1. So you can put square bracket. The second term is given by y of x, which is given. So you're going to say minus x to the power 4 plus x plus 1. So remember, this is all divided by h. Divided by h. So this is the first step, which is this. So now, the second step is just algebra, simplifying. So you should first simplify your first term on your numerator. So as you can see, you have x plus h to the power 4. So you should have something that looks like this. We'll put a template. So you should have your x plus h to the power 4 over h. This is equals to, so actually you have minus y of x, we set it x to the power 4 plus x plus 1. Put the bracket. So this is equals to, so you expand x to the power 4 plus x plus h plus 1 minus x to the power 4 minus x minus 1, which is this. So this is all divided by h. But if you expand here, x plus h to the power 4, you should be able to obtain this here, the expression, which is x to the power 4 plus 4 x to the power cube times h plus 6x squared, h squared plus 4x, h cubed plus h4. So now you have to fully simplify this, and it should reduce to this. 4x to the power cube plus 1 plus 6x squared times h plus 4x h squared plus h cubed. Easy, okay? So let's move to question 2. So question 2, Are the expansions of the following two expressions the same? So you have two expressions. You have to um, prove whether they are the same or not. So to do that, take the first one. So if you take the first one, you will have to expand. So you have your coefficient a into b plus c over a raised to the power cube. So you expand, you keep your a outside, then you expand this, the cubic. So if you expand this, you should be able to get this term inside the bracket. B cubed plus 3b squared into c over a plus 3b into c over a squared plus c over a raised to the power cube. So now what you have to do is to take the product. So you're going to multiply a by this, and a times this, a times this, and a times that. So that's why on your first term you have a times b cubed. The second term, it vanishes this a in your denominator because it get cancelled by this a. So that's why you have 3b cubed, 3b squared times c. With that term, you have c squared over a squared. So this is just this portion. So this is going to be a times, all right, giving you c squared over a. So that's why you have 3b times c squared over a and not a squared. So you do the same for the last term. So you're going to have c cubed divided by a squared. So this is as far as you can go in simplifying this expression. So you stop there. Okay, but remember, you want to compare these two if they're the same. So now you take the second expression and you expand, you fully simplify. So you're gonna have ab cubed, second term 3 into ab all squared times c plus 3 into ab times c squared plus c cubed. And now you fully simplify, you expand this, which will give you a cubed, b cubed plus this, and this. Okay, again, this is far as you can go for this expression. So now compare the two expressions. If you look at these two expressions, they are not the same. Okay. If you want to take the coefficient a, so I'm talking about this expression, into the bracket, this one, before expanding it, the coefficient a must be expressed as a raised to the power 1 over cube raised to the power 3. So actually it's just a equals to a raised to the power 1 over 3 all over 3. Okay, so you can go back, giving you this because these two will cancel. But the main objective to do this, actually you want to express a as this so that it is compatible. So the calculation is done. Okay, so remember, express this as this. So now we have this, isn't it? So you can take it all out. Okay, so this is what you've seen in high school. So actually you can put this inside the bracket and put the 2 out. because you have invisible ones. Okay, so it's a raised to the power 1 over 3 times b plus c over a. Okay, so you can multiply, you can take your product inside. You'll have a 1 over 3b plus c a raised to the power this. Okay, because if c times a to the power minus 1, so now it's multiplied by 1 over 3, a raised to the power 1 over 3. So these are the same base, so you're gonna have a 1 over 3 minus 1. Okay, so this will give us minus 2 over 3. So now the expressions is this, which is the same as this. Okay, and if you expand these two expressions, you will have the same answer.